Today, we're gonna do a tutorial. But first, because it's morning, we are gonna eat our breakfast. Today is March 13, 2020. And now, we are gonna solve some probability problems. But first, we're gonna need a formula. Let's get started. To start us off with our problem solving for today, this is the first question. A coin is tossed 3 times. What is the probability of getting 3 tails? The solution for this is, we would use the formula for probability, which is the number of desired outcomes over the number of total outcomes. When you toss a coin, its probability is 1 over 2 because you have a probability of getting a head or a tail out of those 2 outcomes. For the first row, you get 1 over 2. For the second row, you get 1 over 2. And for the third row, you also get 1 over 2. When you multiply all those, you get the probability of 1 over 8. Meaning, when you toss a coin 3 times, the probability of getting 3 tails is 1 over 8. For the second question, in a family of 5 children, what is the chance that there are 3 boys and 2 girls? Now, the number of total outcomes for this problem is 2. Because as we know, when parents give birth, the only outcomes can be a male or a female, meaning there are 2 outcomes. And because there are 5 children, we have 5 trials, which means we could write it as 2 raised to 5. And for our number of desired outcomes, we would need to get the permutation when some things are alike of the males and the females, which would go like this. And when we compute that, this is the outcome. Meaning, the chances of getting 3 boys and 2 girls in a family of 5 children is 5 over 16. For our third problem, in a certain barangay, 80% of the population has cell phones. 2 persons from the population are to be selected at random, with 3 conditions. Letter A, probability that they both have cell phones. Letter B, one has a cell phone and the other one has none. And letter C, probability that they both have no cell phones. To solve for this, we could write the 80% of the population that has cell phones as 0.8 and the remaining 20% of the population without cell phones as 0.2. For the first condition, probability that they both have cell phones, we would use the percentage that they have cell phones to get the probability that they both have cell phones, meaning 0.8 times 0.8 is equals to 16 over 25. For the second condition, one has a cell phone and the other one has none. We would multiply the percentage of the population that has cell phones with the percentage of the population that has no cell phones. And because there would be 2 scenes in which either one could go first, we would add the 2 scenes together. which would equate to 8 over 25. And for the third condition, or letter C, probability that both have no cell phones, we would use the remaining 20% or 0.2 of the population that has no cell phones, meaning 0.2 times 0.2 is equals to 1 over 25. And for our fourth question, the probability of event X happening is 3 over 5. The probability of another Y happening is 2 over 3. With the conditions, probability that both X and Y will happen, and B, probability that only X would happen. To solve this, we would first need to know what the probabilities of the happenings X and Y and what is the probability that they would not happen. To get the probability that they would not happen, we would just subtract the probability that they would happen to 1, because 1 is an absolute probability. Meaning, 1 minus 3 over 5 is equals to 2 over 5. And then, 1 minus 2 over 3 is equals to 1 over 3. Then to get the condition A, we would get the probability that of both X and Y, and then multiply them, and then this is the answer, 2 over 5. 2 over 5 is a probability that both X and Y will happen. And for the second condition, probability that only X would happen, we would get the probability that X would happen, which is 3 over 5. And then the probability that Y would not happen, because it says that only X would happen and not Y. Meaning, we would get the probability that Y would not happen, which is 1 over 3. And when we multiply them, we get 1 over 5. For our last question, or problem, a restaurant has 3 kinds of toys, and is giving 1 toy for each purchase of a kiddie meal. Find the probability of getting the 3 toys in 5 purchases. The solution for this is, first, we should know the number of total outcomes, which is, we have 3 toys in 5 purchases. We could write it as like this. And when we summarize it, we get 3 raised to 5. And then to get the number of desired outcomes, I labeled the 3 toys, toy 1, toy 2, and toy 3, X, Y, Z. And because it only says that you need to get the 3 toys, just the 3 toys in 5 purchases, you have 2 more slots. Which means you could put XX, XY, ZZ, XY, XZ, and YZ. Just like in the previous problem that we have, we would use the permutation when some things are alike. Get their values, 5 factorial over 3 factorial, 1 factorial, 1 factorial is equals to 20. And that, so on and so forth. And when you get all their values, you add them to get the number of desired outcomes. Once you get the number of desired outcomes, evaluate, and then you get the answer, 50 over 81. The probability of getting the 3 toys in 5 purchases is equal to 50 over 81. That is all for today. Thank you for watching, and see you next time.